The first 5 questions on this lab are all on the same page of the workbook. They're all in Beyond the Numbers 2.6, and they're all on page 146. The first 3 come from Exhibit 2, which begins on page 145. That's where the box is, but all 3 of the questions are at the top of page 146. For the first question, I think the best thing to do is write the answer out in list form. So just to list out the possible samples. If you're going to use abbreviations, I'm okay with that. Just use the conventional ones. So R for Republican, D for Democrat, that kind of thing. Number 2 and number 3, for both of those, the answer is a single fraction. There won't be any partial credit with those, and there's not really anything else that you can write out. So those are really short in terms of what you'd have to write, that's for sure. Exhibit 3, down below on page 146 in the workbook. The population, that shouldn't be too bad. I guess the only thing that might potentially be troubling is being specific enough. So just use everything that you can use there. There's not a lot of wording to work with, but just use everything that you've got to write out what the population is. And then for number 2, describing in detail how you would select a simple random sample. For that, what most people tend to do is give a description of the picking names out of a hat concept, which is probably the easiest thing. And that's going to be the most straightforward thing to do. Just make sure you're as descriptive as possible. Another option would be if you wanted to describe how you would use a randomizer to do it, you could do that. If you were going to use a randomizer, essentially it's this. So this is randomizer.org, where you just have to specify a few things. The first of those 4 blanks that you need to enter some numbers into asks how many sets of numbers do you want to generate. That's asking you how many samples you want, and we just want 1. Then how many numbers per set is effectively asking you for the sample size, and the number range is asking for the population size. Because in order to get this to work correctly, what you would have to do is you need a list of everybody in your population, and you have to assign them a numerical label. So I'm going to intentionally use numbers that aren't in the workbook. So I'm going to say we want to take a sample of 45 from a population of 300. In that case, I would need to list out all 300 people and assign a numerical label to each one. So from 1 to 300 would be the easy way of doing it. So the first person on the list is labeled with a 1, second gets a 2, third gets a 3, last gets a 300. Then I want to sample 45. So that's how many numbers per set. That's where your sample size goes. Everything else you can leave alone and then randomize now. What randomizer.org will do is it will give me 45 randomly selected numerical labels, and then the individuals that correspond to those labels would comprise my sample. So the individual that has label 23, they're in it. And then the individual with label 238, they're in it, and so forth. So you can do it that way if you want. Most people are going to do picking names out of a hat, which is perfectly fine. Just make sure you're descriptive whichever way you do it. Beyond the Numbers 1.14, Exhibit 1, Question 2. So the Exhibit 1 box is on page 45, but Question 2 is at the top of page 46. So you want to find 2 reasons why the inference might be compromised. There are more than that, but 2 is enough, and if you give more than 2, then the first 2 are going to be the ones that are graded. The one thing that I will say is that the different sample sizes is not a correct answer. So where it says subjects as a subheading, and then 40 undergraduate students were enrolled in online courses, 59 in in-class courses, that's okay that the sample sizes are different. So that's not a reason why the inference might be compromised. There are a few others, though. Some of them have to do with confounding. Some of them maybe have to do with how the students ended up taking either an online course or an in-class course, who made that decision. So was that assigned to them, or did they get to pick it themselves? I can give you an idea of what I want as far as the confounding, or what I think you should look for with the confounding, using Beyond the Numbers 1.15 Exhibit 1, which I have right here. There's a screenshot of Beyond the Numbers 1.15 Exhibit 1, and there are a bunch of confounding issues in here. One is that the 2 groups of students come from different years. One's 1997 and one's 1999. They go to different schools. We have a Los Angeles school, we have several Orange County schools, and if they're going to different schools, they're going to have different teachers. So certainly the possibility of confounding there, right? If the idea is that you would generally want things to be similar except for with respect to whatever your explanatory variable is. It seems like you could get a big difference if they had different teachers. And just going to different schools by itself is probably a big difference as well. One group only had automated instruction, and the other group had automated and traditional instruction. And then the grade level's never specified, so that's a possible source of confounding. Right at the very end of that exhibit, it says, concepts usually not introduced until 6th grade. So all that we know right now is that those students aren't in 6th grade yet. But what if one group is in 4th grade and one group is in 5th grade? A 1-year difference at that age is going to be enormous. So that is a possible source of confounding. So look for those with that question from Beyond the Numbers 1.14. And then also you might want to look at how the students were ending up in the courses. So if they were picking it themselves or if it was being assigned to them randomly. However that was being done, look for that. Going back to the original PowerPoint, then we have a couple of questions from Beyond the Numbers 1.21. That first one, the first exhibit, really you're just matching up the letters to the numbers, and the two that are already filled in the table, I think you can pivot off of those to get the rest of them. And writing out the answer, I think it's just 1 and then whatever letter goes with it, 2 whatever letter goes with that, 3 whatever letter goes with that, and so forth. On the back, we have something where you have to arrange the two crops, the A's and B's. I think the best way to put that into a Word document would be in a table or using a table. So here's my Word document. There's the 8 for question 8. And if I go to Insert Table, and I'll make it emulate what's there where I have 3 rows and 8 columns. And then if you want to adjust this, I think those cells look a little wide, so I'm going to make them a little smaller. And then you would just put the A's and B's in here, right? Something like that. The 3 A's in a row may be completely incorrect, so just be aware of that. Okay, 9 and onward are all just on the worksheet. So for 9A, that's a yes or a no. There's nothing extra to add in. 9B, it's a bad sample. So that's the thing that needs to be explained. Is that a convenience sample or is that a volunteer sample? That's really what you're looking at there. Those bad sampling methods are talked about in the video for section 1.2. That's probably the best reference point here. So just, is it a convenience sample? Is it a volunteer sample? If you want to put a justification in there, that's probably a good idea. That doesn't have to be very long, but that's certainly something that wouldn't hurt. Then part C, that's a one-word answer. Either it's a quantitative variable or it's a categorical variable. 10 and 11, watch out for those because it's very easy to just have an answer that's one of the possible values. The thing that I would look at would be in the section 1.3 lecture, there's an example about green tea extract, and I have the explanatory variable written as green tea extract or placebo. That way both possible values are covered. Just green tea extract by itself, if that was a graded question, would be half credit because that's 1 out of 2 possible values. So something like that, or the response variable for that question in the section 1.3 notes has a whether or not. So I think it's whether or not they developed cancer. So either they did or they didn't. Those are the 2 possible outcomes. Those are the 2 possible values for the response variable. The whether or not thing is helpful. You're probably going to want to use it at least once, maybe twice here. Then number 12, those are all yes or no answers for A, B, and C. That's about all you can write. And again, the material in number 12, that shows up in the section 1.3 notes. Number 13, identifying the sample and identifying the population. The one thing I want to point out there, specifically for A, identifying the sample size is not enough. So 2,861, if that's the entirety of the answer, that's going to be wrong. That's not descriptive enough. That's part of it. That is the sample size, and that is the thing that you want. But 2,861, what? Make sure that you have that as descriptive as you can get it, which really won't be very long. I think you can write it as 2,861 with 3 words after that, and that's about as long as it needs to be. Then the population of interest, once you have the sample, I don't think the population's too bad. And then part C, the variables in the study, there are 2 of them. So you should have 2 variables and identify each one as quantitative or categorical.